what I'm calling F# for web developers. Actually, I'm going to open the chat. Feel free to heckle alongside if you must. I will try and keep an eye on that while we go. Yes, ask questions as we go. I like doing talks that are interactive because that's the way that you get the most out of it, is that you ask questions along the way. My name is Aaron. I work for Microsoft in the developer advocacy team. I've been doing web for about 15 years now, or at least I'm going to say 15 years because anything more than that makes me sound really old. And I don't want to admit to that just yet. I've been in Microsoft for about 2.5 years doing this kind of stuff. But I started with things like classic ASP and VBScript and web forms, and that was kind of what I grew up on from a web tech stack. About a decade ago, though, I started trying to explore different languages that were designed to support .NET, things other than C# and VB.NET. And one of them that I came across was F#. So I've dabbled on and off with F# for about 10 years now, and I think it's a great language. I think it's something that more people should be aware of. I'm not going to tell you have to use F# and it has to be the language for you or anything like that, but I think it's a good one that you should be familiar with. If you want to get in contact with me, you'll find my details on the screen. It's down there, I think, below me, if you want to ask questions or anything else after the fact. Oh, yeah, and I'm in Sydney, so I should show you what it's really like in Sydney. There we go. There is literally COVID everywhere. So, as I said, today I'm going to be talking about F#, but I'm not going to be doing an F# 101 talk. This isn't an introduction to the language and the language primitives and things like that, because there's plenty of that content out there. I'll have some links at the end if you're brand new to the language, you've never seen it prior to this session today, and you want to learn some more of the fundamentals. Instead, I'll show you how to use F# in an application sense so you can get an idea of what it looks like from a program, not just from a syntax standpoint. But don't worry, I'm pretty sure you'll be able to pick up the stuff as we go along pretty quickly. Like I said, I've been dabbling on it for a long time, so hopefully I'm going to do a good enough job of explaining the stuff that we've seen as we get into demos. And I'm also not going to say, like, this is why it's better than C#, because it's not this one versus the other sort of conversation that we're having. But we're here to talk about F# for web developers, specifically for front-end web developers. So the kind of people that are building JavaScript apps. And you might be going, what the heck? Like, it's a application for, like it's a language for doing .NET programming, right? But what is it like for front-end apps, for JavaScript developers? Why is F# relevant for JavaScript developers? Well, you better stay around for the session because I'll explain that. If not, then and you leave now, you're just never going to have the answer to this question, and that's going to be very disappointing for you, I'm sure. So you've got an idea. You're going to be building a web application. It's going to revolutionize the world. It's all that kind of cool stuff. And I want to build it in what I still refer to as like a modern web application. One that's not sending full pages to servers, like because that's what I grew up building, was like web forms. And I remember when like update panels appeared, I was like, oh, it's amazing. We don't have to load a whole page. We're only loading parts of a page. But it's the kind of application that is probably very UI heavy. Like there's a lot of stuff that's happening within the browser that is making it very dynamic. You're only sending back small bits of information to the server, and then it's just progressively updating the page as it goes along to respond to changes they're having on the server. So that's the kind of application you want. You want that for users. Now, you're going to need to store data as well, because it's not going to be a particularly useful application if it's exclusively read-only. So we want a way that we can do that kind of end-to-end integration with the interactions with the user. So for this, we're going to be using Azure Static Web Apps. So Static Web Apps is one of my favorite services in Azure, or at least at the moment. You can't have one favorite for all the time, because the cloud is an ever-evolving platform and yada, yada, yada. But Static Web Apps is something I've been doing a lot with for the last kind of 18 months. And it's designed for hosting front-end web assets. So your HTML, your CSS, your JavaScript, that kind of stuff in kind of a way where you don't have any need to think about infrastructure. I guess you could almost think of it as like serverless, but for the UI files that you send down to a client. But static web apps also gives us an API backend built on Azure Functions. So it's really good that I was following David's talk before, where he's introduced you to Azure Functions and some of the things you can do with that, because you can build your Azure Functions in .NET and have them available for a static web app. And it's really easy to deploy because we can use GitHub Actions. I don't have to think about creating CI/CD. I just click a couple of buttons in the Azure portal and it creates CI/CD pipelines for me. Excellent. Sounds like a great starting point for how we build an application. But we have a problem. You'll need to know JavaScript. If you're building this rich UI experience, you're going to have to write JavaScript. And I know for a lot of people, I've done JavaScript for a long time, but I know a lot of people haven't, and I know why people don't like coming to JavaScript. I know that there are problems with the language, and I know why people dislike it. But more than that, more than not wanting to learn JavaScript or not having to deal with the nuances of that language, you now have a disconnect between the way that the server is going to talk about data structures and the way the client is talking about them. So you're sending back some JSON payloads over a HTTP request that you're unpacking at the client, but if you change the structure of that at the server, you then have to make sure you update your TypeScript definitions or whatever it is on the client so that you can understand that. Or you could have a chance where you're sending data that the client doesn't know about, or you're no longer sending data that the client expects. So we have this problem because we have that sort of a mismatch that's happening there. So then, you could go full JavaScript and you have TypeScript Azure Functions and TypeScript in the client, but now we've just compounded that first problem. But then there's still one more problem, and that is you have to decide which JavaScript framework you're going to be using. It's going to be React or Angular or Vue or Svelte. You're going to use a meta framework like Nuxt or Next, or I could probably go on all day, and that's just the ones that were released in the last 24 hours. And tomorrow there's going to be an entirely new set of JavaScript frameworks. So you're going to have to learn and make a decision. Are they the right ones for you? And are they going to revolutionize the way we're doing web applications? What if we could use the power of .NET and do this sort of end-to-end? Well, let me introduce you to Fable. Fable is an F# to JavaScript compiler. Yep, that's right. An F# to JavaScript compiler. You're probably going, why would I ever actually want to compile JavaScript from F#? It seems kind of weird. If we wanted to do .NET, well, we could go down the route of Blazor. But Blazor means that we've still got to load up a WebAssembly VM, and so we have to ship WebAssembly, and it can be quite a heavy download experience for someone that wants to use your application. So but whereas if we're submitting something as JavaScript, and if it's just JavaScript, well, that can be potentially more optimized. But this is it's a great idea. If we can write F# in the client and build our web UIs with that, well, maybe we can also share code with our server. So we can have the same data structures, and we can literally share those code files between our client and our server, which makes it really easy to do interop. Now, Fable is a tool for just doing a compilation of F# to JavaScript, whether it's in the browser or running anywhere else you might be running JavaScript. In fact, I know a bunch of VS Code extensions are written in F# that are compiled to JavaScript, including the VS extension for VS Code extension for F# is written in F# that's compiled to JavaScript to then work with F#. Yeah, that kind of makes a lot of sense, doesn't it? Thoroughly confused of what's this idea, and why would we want to do this? So let's depart from the slide deck and have a look at actually some demos. So for this, I'm going to be using a GitHub repo template that I've created that you'll find here on my GitHub repo, github.com/aaronpowell/swa-feliz-template. And Feliz is a library that's been created for Fable, which allows you to do React-style programming in F# that compiles to JavaScript. Okay, like I said, stick with me because it does sound kind of weird and wonderful at the same time. I've gone ahead and scaffolded up this project, but if you're curious of the command, it was, so I used the GitHub command line, so gh repo create, it's a public repo, provided with a template and a description. So that's set up and it's all ready to get running. But this is what we get. We get a client-side application and an API application. So that's the Azure Functions. Oops, there it is. So we've got API where our Azure Functions live and a source folder where our client is. We're going to kick this off. So let me just start up that. Actually, no, we're going to debug, and we're going to launch it all. I'll keep this off. I can run in the background while I talk a bit about what we've got here. And let's get rid of my terminal. Okay, so our entry point is this app.fs file. So this is our React application. If you've done React before, this is probably, while symbols are probably different, it's not too foreign to what you would have written with React. We have an attribute here that's just denoting that this is going to be a React component. We're using a let binding that is essentially a variable assignment, similar to like var in C#. We're creating a function called counter that takes no arguments. We're going to use React, a function component, so it doesn't have state itself. So we're going to use React hooks to do that. And this is going to return me a tuple, which I unpack as the local variable int, local variable count, which is of type int, and then the mutator function, which is going to take an int and return a unit, which is equivalent to a void, at least for this context. And then we're going to create some HTML. We're going to create a HTML div. It's going to have a h1 in it, which has got the count value assigned. And then we're going to create a button with some properties, one of those being the text property, which is going to say increment. And then we're going to have an on-click handler, which when invoked, it will call set count and increment that by 1. Now with F#, we don't have to use a return keyword. So this is an implicit return. So this is how we end up with that HTML being rendered out. Now let's see if that is up and running. We'll check the emulator. Emulator crashed. Start that back up. And we'll open this once it tells me, once I get there we go, open the browser. Excellent. So this will take a moment or two to download all of the files because for local development, I'm actually using ECMAScript imports. So the import keyword in JavaScript, because we're running JavaScript at the end of the day. So it's downloading a whole stack of files. This is running an unoptimized bundle. But this is our application. I've got a button where I can click and go increment. Look at that. I can make the number go up. Amazing, isn't it? But if we come over to our, go away there, sources folder, I have a file here, which is app.fs, and let's chuck a breakpoint. We'll just chuck it there. Ta-da! I'm now debugging F# code from the browser developer tools, which is actually running JavaScript at the end of the day, but just the same way as I could be debugging anything else. We can step over all of these variable assignments. We'll see that count is 19, which is what it should become, so on and so forth. Excellent. I could also call this message from an API. So that's then going to call this Azure function that I've got. It's going to return me back a message, which I'm outputting there. So let's have a look at that piece quickly. So this is a second React component that we've got in here. It is again, it's got the React component there called message. We're using some ReactState, which is starting off as an empty string. We have our HTML div with a button with some text. It has an on-click handler. And this time we're doing an asynchronous operation, or in fact, we're doing an operation that will result in a JavaScript promise being executed, which is asynchronous for all intended purpose. But you'll notice this promise keyword first up here on line 23. This is a computation expression in F#, which is indicating that something inside of here is going to be handled a little bit differently by some sort of external builder library, which is in this case called a promise builder. We do let bang. Let bang indicates that whatever we're doing on the right-hand side of the assignment operator, that's going to be processed by our builder computation expression. And this is, for a loose analogy, same as doing a wait function call in C#. So fetch.get is going to do a HTTP fetch. It will then, using the get method, it's then going to return some data, which as a promise, it's going to unpack that promise. It's going to become a string, which I assign to set message, which I call set message on, which we then update our local state. But we do have to do a return here. This is the computation expressions are the only places where you need to return explicitly in F# rather than implicitly, which is the rest of what we do. But I don't care for any particular return value, so I'm just using a unit here, indicated by the empty parentheses, and we're going to start that promise. So it's going to execute as soon as you click that button. If there was a message, if there wasn't a message, don't put out anything in the HTML. If there was, put out a p tag containing said message. So that's going to call up here into our getMessage Azure function, which we know all about Azure functions now, thanks to David's lovely talk. And we've seen HTTP triggers in action. So the difference here is that this is written in F#. We have our function name called getMessage, a HTTP trigger with our metadata around how we're doing a HTTP trigger. And this time we're using an async computation expression to perform something asynchronously in F#. And we'll see the use of that down here on line 37, where we're doing a let-bang binding to bind the value of request body to the result of unpacking an asynchronous operation from reading that string. One difference here with C#. So this kind of thing is like having like this async computation expression is similar to putting like an async keyword on a C# method, and then let bang in this case is like doing await stream.read to end async. The only difference is that we're using the F# async of t rather than the C# task of t, and we're having to convert back and forth. It's a little bit clunky, but there's some proposals to improve the F# language to do better interop between async of t and task of t between F# and C#. Other things that are happening in this function, we're trying to read out the query string, checking to see if there's a particular parameter. If there is, it's going to be assigned some value to nameOp, otherwise it's going to be none. So instead of having nulls, we just have what's called an option type. Does it exist? If it does, it contains some value, otherwise it contains a none value, which means that we can then do pattern matching down here for some assignments. Match to see whether nameOp is a sum of something. If it is, just unpack that value. Otherwise, if it's none, look to see if we can deserialize a body request. And that's a basic F# function written to respond to HTTP request, which we can do back and forth between our client. That's great. Like, this is still a very disconnected application. The client and the server only talk to each other by HTTP. They're not sharing any message contracts, so we're just sending text back and forth. Let's have a look at a slightly more complicated application. This is a trivia game. Actually, I will come back to this first one and stop all of our debuggers so I can start them and make sure I don't have any port conflicts. And we are going to launch that. Debug, launch it all. That's the one I want. So we'll kick all of those off in the background. Got it. Close that. Click that off in the background while we have a look at some of this code. So this one is a much more complicated application. It's a trivia game where it's ultimately going to write to CosmosDB and read from CosmosDB. But we'll start off with our app. So I have our app up here. This is the entry point. Now this application has multiple pages, so we've got the concept of routing introduced. I've defined some types. This first type is what we call a discriminated union in F#. And it's just indicating the different pages that I could be on, kind of like a superpowered enum. I could be on the home page, join, play, results page, or 404 page and not found. And I can pass some data across to that to come in, I guess, with that discriminated union value. So join is going to receive a string, play is going to receive a tuple of string and string, same as results is going to receive a tuple of string and string. But I can strongly type how that tuple is represented and then use that within pattern matching, like we do when we parse the URL. So the parse URL, whoops, if I don't scroll too fast, is going to receive a list of strings, which is going to be the segments of the URL. If there's no segments, then we're going to return the home page. If there's a first segment is game, and then the second is, well, anything, we're going to unpack that as a variable called game ID. Well, that's going to match join. Game ID, player ID. That's going to be play for a particular player in a particular game, and then simply for results. If the pattern matching failed, we're going to return a not found page. We can then use that inside of a React component. We can create some state, parse the URL from the current URL of the router. So that's what's going to be the current page. And then we can pattern match on that. If the current page URL is home, render the home page, join, get the game ID out of that, and then return the join page, et cetera, et cetera. I think all of our servers should be started. So let's just have a look. The emulator did again crash. Sometimes the emulator starts before all the backend servers are up and running, so it falls over. So I have to restart it, and that's where that happened. Let's fire that one up in the browser, close that tab because I no longer need it. And we'll have a look at, say, the join page, because now we've got a React component that's receiving some props. This prop is an anonymous record type indicated by these the squiggly brackets and the pipe operator. So this is an anonymous record, similar to, I guess, anonymous classes in C#, but we can create them and use them sort of in line like this, which we have game ID and a function called onStarted, which will take an argument of in progress game and return a unit value. Setting up ReactState, we have a React use effect. So when some state changes or when something happens, we'll perform this effect. So if we're in a joining state, so we've clicked the button to join a game, we're going to fire off a new promise, which will then add the player to the game. We will then wait for that to be returned. So we're going to await the result of that put operation. We're then going to get the game info by starting the game. And then eventually we're going to call props.onStarted to start our game and then navigate across to the play page using the player information. And then lastly, we output some HTML at the end, which is the game screen that we're currently on. I could clean this up and pull these out into my actual functions that are within inside of this this file, but I've just got everything in line, which is why we get a bit more of a Christmas tree experience than maybe so desired. Let's see, still loading, or has it crashed loading? Let's find out. Let's have a look at our elements. No, console. I think it's still probably just downloading a massive ton of files because we haven't got a single optimized bundle at this point in time. Yep, there goes the request graph. Okay, while that's running, let's have a look at the APIs that this might be calling. Let's start with add player to game. We have our Azure function here. Again, it's a HTTP trigger. So this is going to be coming in on a request. It's a put operator, so a put method on the request. The route has some things that we're binding into it, game ID and name. We're then passing that across to CosmosDB so we can pull out some information. And then finally, we've got some outrefs. So this is how we're sending data back to CosmosDB. Outref is the equivalent of an out parameter on a C# function. Some pattern matching. Is there an existing player inside of the sequence of players that we got back from our CosmosDB query? If there wasn't, create a new player. This time we're using a typed record or a non-anonymous record, indicated by the fact it doesn't have the pipe operators either side of the squigglies. So this is of type player, which exists within inside of our type system. If I was to go to player, it's in a different file, is it? Yep. It's in the shared types. We have our type player, and this is the same one that is then used. Let me just see. I think we should get it. That type is actually the same that is available here. Game with player. Oh no, that returns a game, not a player. Forget where I returned that one from. Anyway, that's right, we create a game, which is this type here. And if we were coming to game, and then we do shift F12, we'll see that, there we go. So the type is also used inside of our client-side code. So now if I was to change the game here, so if I was to change it from questions to question, just for funsies' sake, that would break in here, and it would also break in addition. So that's been shared across everywhere. So we've created our game, we've created our player, we've added them to the list. Let's have a look to see. It's still not downloading all. It's doing something. I don't know what my machine is doing, but it's downloading a bunch of files. So this demo is not going as smoothly as I would have hoped. I did not sacrifice the demo gods as I should have beforehand, but we will carry on. So I see there's a question in the chat about the CosmosDB attribute. So I'm going to assume that the question is related to this one here. If not, just ping in the chat. So this first one here is an input binding for CosmosDB. We're saying that we want some data out of Cosmos, and we want it provided into this Azure function when it requests. So the actual thing that will trigger the function, what makes it start running, is a HTTP trigger, but we're also going to provide some additional input. So CosmosDB, it's a particular database and collection using a connection string. And then this SQL query has a parameter out of the request URL injected, which will then turn into a player sequence, which is equivalent of an INumerable. For the output, we then have our outrefs at the bottom if we want to write them back out at the end of our response. And so that's how we would do an update operation. So it's an output binding in Azure Functions. All right, well, I'm going to give up waiting for this because it's taken way too long, and I'm going to assume that something somewhere has crashed, and that's probably enough of me faffing around trying to wait for demos to succeed. You can go check out a working version of that up on my GitHub elsewhere. Now let's swap to the right section of slides. So I'll wrap up now. It's getting late, and the semi-final hockey is on tonight, and I want to go and watch that. So Olympics priorities. Sorry. Okay, so to wrap up, here's a couple of useful links. So Fable, Fable.io is the thing I was using to compile F# to JavaScript. There is actually a pull request out, or I think it might have just been merged, to compile the F# code to Python code. So if you wanted to compile it to Python for a different use case than running in a browser, you can do that. I'm actually quite interested in that because I've started playing with Home Assistant for home automation, and I don't want to have to learn Python. So I'll compile F# to Python. Why not? The demo application that I failed to get running there at the end, you'll find on my GitHub, github.com/arrowpower/fsharp-hwa-trivia-app. You will have to supply your own CosmosDB connection string. I'm not publishing that to GitHub. That would be a terrible idea. But the instructions are there to kind of get it up and running, along with a link to a live stream where I went through this in a lot more details. And as I said, if you wanted to learn more about F#, there's a couple of links that I've got here. So over the last about 2 or 3 weeks, the Docs team at Microsoft have been releasing a learning pathway around F#, kind of introducing the language to, I guess, a new audience. So this covers off language primitives and how to get started, building your first bits of code with F#. I think there are up to 5 modules on MS Learn. And similarly, the author who's been creating those MS Learn modules has created a video series on YouTube. I think there's like 15 or something videos where he goes through all the fundamentals of F# to get you up and running. But that'll do me for this evening. Thank you for letting me show off a language that I think is a great one to have in your toolbox and to use it in a way that most people probably never thought you should, which is compiling a .NET CLR-based runtime language to JavaScript.